Good afternoon, everyone.
Good day.
Hello.
Good afternoon. Dear authors and invited guests, welcome to the technical session 6A. Myself, Aarti Mohan, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Congress on Information and Communication Technology, ICICT 2025, London, UK. The 10th edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in London, and the virtual event is being held through Zoom from 19th to 21st February 2025. I hope you all would be enjoying this knowledgeable and interactive session through the day. In this session, we have 6 presentations. Each presenters will be given 12 minutes for the presentation and 3 minutes for the question and answer session. On 10 minutes, I'll raise a gentle reminder. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any sort of query or any update, you can write it to me in the chat box. Just before we get started with the session, I would like to introduce you all to the session chairs for this session. We have Professor Alexander. He's a professor. He's a professor at State University of Trade and Economics, Ukraine. And we have Dr. Praveen Chopala. He is currently an associate professor with the Department of Electronics and Communication Engineering, Andhra University, India. His research interests intersect the domains of signal processing, machine learning, and Bayesian estimation for a class of multidisciplinary applications in engineering, biomedical sciences, and economics. We welcome you, sir, on board with us. I would request our session chairs to please provide some opening remarks for this session.
Good afternoon.
Good afternoon.
It's very unusual, and it's very important for me to start our session. I would like to welcome all our visitors, and I hope we will have a fruitful cooperation. And I wish you a good luck with your report. Please ask any questions to everyone, and I think, I hope that our meeting will be very interesting and very fruitful. Thank you.
Thank you. Thank you so much for your valuable remarks. I would request Dr. Praveen, sir, to please provide your remarks. Okay, moving with our first presentation for the day. We have paper title Algorithmic and Information Support in Atmospheric Air Quality Monitoring System. Dear presenter, could you please start with your presentation?
Yeah, of course. 1 minute, I'll share my presentation for you. Okay.
Praveen sir, in the meanwhile, you can share your remarks, please.
Yes, I'm sorry for the delay. I'm actually looking forward to hearing the talks from our esteemed participants, and I'm also looking forward to learning something new. So I welcome all the participants, and I thank the organizers for inviting me to be the session chair for this session. And yes, let us kick off and looking for a good time of discussion.
Thank you. Thank you so much, sir, for your valuable remarks. Yes, the screen is visible. You may please start with your presentation.
Yeah, thank you so much.
Hello, everyone. My name is Dmitry Shevchenko, and I'm a PhD student. And today I will present you our scientific job. It is algorithmic and information support in atmospheric air quality monitoring system. We know that monitoring system is a big challenge for us because pollution is increasing and ecology data is complex and our ecology is changing, and we need to be flexible, and this system should be accuracy and reliable. So this research will explore how to improve air quality monitoring system with better algorithms and data management. So we focus on data processing, on system architecture, database and index calculation, and some of additional algorithms with optimization. You see this? Yeah, so you can see this system architecture that was developed, and it consists of IoT sensors in the sensors. It is a station that calculate and obtain data from our environment and send this data to our system by via MQTT protocol. And you can see other third-party services like SafeEcoBot and KMDI. It is like our system, our our Kyiv city administration. Yeah. So, and the next very important model, it is data collection. Data collection and monitoring system. It is our internal model that collect this data from other different sources and validate, save to database. And after that, it can calculate our own indexes by two algorithms like a common air quality index and air quality index. And after that, we can we have a client side where any user can open our monitoring system and analyze analyze stations state. Yeah. So the next step, it is for any system like this, we need to understand that we need to build a good database and for storing our information. And it is only main tables, but very important and very useful. You can see the station with geolocations, measured unit, and measurements that are storing raw data like a value and timestamp and relation to our stations and measured unit, and breakpoint tables that we are using for our index calculation and for our dashboards and charts. Yeah, so we have already a working system that available for users, and you can see stations on the map that are active, and you can see their state. You can analyze breakpoints that are using for algorithms, and already our system have more than 7 million records in our database, and we will continue to collect new data for our next steps. On this slide, you can see a very useful tool. It's like a tool that can be used from anyone and by a scientific person like a ecologist, and analyze any station by any period. You can select measured unit, period type, and average type. It can be like hourly or daily aggregated data, and you can analyze for your from a solution. Yeah. So we have collected data, and we understand that when we build a system like that, we need to understand that how was our database big? Yeah, so we need to predict our storage for our database, and we know that our one row in database in table measured unit, we have like a 64 bytes. So we can predict that one station each day save to database 1,440 records. So per year it will be like 20 megabytes. And you can see another example. If we have a big list of active stations, it's like 1,000, our database will cost for us 20 gigabytes per year. So it like only per year. And after discover this information, we discussed this info with our ecologist, and we learned some information that we cannot store all detailed information for all periods. We can store only detailed info for last 3 years, and another data can be stored like daily aggregated value, and it is a good way because we can optimize our storage for our system in the future. We discussed database, and we understand that our system have a big list of data, and I want to show you a few points that can help for us to reduce server response time. It's the caching and pre-aggregation. Caching, it is a very common useful tool in modern software systems, because we can store some information for a specific time in our server memory or like a non-NoSQL database like Redis, and it reduces our server response time to 150 milliseconds, and it lowers server loading too. And the next step, it is a pre-aggregation. We can calculate data in process in memory, yeah, but we can we are smart, and we can move this logic to our database. We can delegate this aggregation logic to Postgres. It will be more efficient, and it will be more fast than if we are processing it in memory. So and it cuts response time too, and it is good news for us that we can combine in both methods and use optimal performance for our server, and we can reduce response time to 50 milliseconds and server load to 30%. Not all of us maybe sometimes think about sorting algorithms, but I want to say that we have to be focused on this. If we are process a big list of amount data in our memory for some analyzing or for algorithm calculation, and I want to say that this slide show you some comparison of sorting algorithms, but I thought about it, and I want to say that you can choose any algorithms that you want, but the main thing that you need to be focused on time complexity. Time complexity is the main idea which algorithm will be more better for your decision. So time complexity is the point that we need to focus when we are choosing some algorithms for our sorting system. Conclusions. I want to say that we really built a good system that are working, and anyone can open this system and analyze some data. So system architecture was designed, database was developed, and we have a processing our own algorithms, index algorithms, and we using some of optimizing algorithms. Yeah, so maybe in future we will, I think, not maybe, we will try to use some data mining for, if we have our own data, we wanted to improve our system to help in decision making for our government and country. Yeah. Thank you so much. Do you have any question?
I have one question, if you don't mind. Thank you very much for your report. I know that Ukrainian scientists, maybe 20 years ago, maybe more, have used a special weather box as a box with different devices to estimate different features or different parameters of weather, air pollution, and others. Please, for field investigations, for example. What about this weather box? What about this field investigations? Have they include into your algorithm of air pollution investigations? And how can we use these devices in weather box, maybe modern, brand new, modern devices with your algorithm? Thank you.
Yeah, thank you for your question. I want to say that when we are developing our system, you can see, a high level on this scheme. Yeah, so it's IoT sensors and IoT devices. Anymore, we can integrate any stations for our system. If you understand protocol, and we can exchange data and obtain data from any stations. It's like a box, yeah, so I don't remember the full name. So we can integrate any stations if you understand the protocol, and we have ability to connect and integrate this sensor. We can scale our we just add new source type to our system, and our system start collect this data from new source. So it's not hard for us.
Thank you.
Hi, Dimitro. Thanks for that very nice presentation. My only question is, have you considered using parallel processors to address the speed issues when you work with very large data sets?
As I remember, as I understand you correctly, I display for you that we have already accumulated more than 7 million records. And when we tested speed, on this slide, you can see that we have several types of periods. It's like a daily, weekly, months, and year, and we can use maximal period. It is a year for high loading in our system, and we saw already. In a moment, we can see that our system can be slow or can be fast when you use some of algorithms for destinate a fast response from the server. So this technique we used for in our system. So we just use a maximal period and analyze which algorithms will be more efficient for our large of data set. Yeah.
Thank you. Good work. Good work.
Thank you.
Thank you. Thank you so much for your presentation. Professor Robert, you have any questions?
So just one question, if I may. You were speaking about algorithmic complexity, and that you have some work there. So what is the complexity of your algorithm? What is the efficiency? What is the convergence? And what work will you do in the future? Thank you.
Okay, thank you so much.
Thank you.
Yeah, nice question. I think I have a area for improving my system, because it was like examples, how we can analyze algorithms, because now we have we move our so we move this logic to our database, so we can use that we can discover, I think, in the future more information about because we have a plan to exchange our system with regression model, where we will use only raw data, so not aggregated. Because now we prepare already aggregated data in our system. And sorting algorithms we just analyze for our future next challenge in our system. It's like a regression, analyze relations between measurement types by regression, and using raw data for data mining. But it's a good question for future understanding. Thank you.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. We have classifying customer feedback using machine learning, a case study on the smartphone suppliers VOC dataset. Dear presenter, could you please start with your presentation?
Hello everyone. I would like to present biovisual. Hello everyone. My research team and I are very pleased to participate in today's conference. I would like to present our research topic, which was conducted by three people: myself, Nguyễn Ngọc Tú, Associate Professor Phan Duy Hùng, and Mr. Vũ Thu Diệp. The title of research is Classifying Customer Feedback Using Machine Learning, a case study on the smartphone suppliers VOC dataset. My presentation will consist of 5 parts. The first is problem and motivation. The second is data analysis. The third is data pre-processing. Following that will be the view model and the result section. And finally, the conclusion. The issue we addressing is on each mobile phone from different companies. There is a pre-installed application. When you encounter problem during their phone use they use this app to submit their feedback. Their feedback is then forwarded to the customer service center for resolution. As the company employ it, the complaints daily and respond to the customer. Technical issue are forwarded to the IT department for resolution. This entire process is done manually. Therefore, this project to clearly classify the problem customer face when using the company's product through deep learning. The project will help improve the company's product quality and customer service. This is a style of data we collected from the company's system. The dataset consists of two attributes and 41,886 feedbacks inside from various customers or in Vietnam. Each VOC for each voice customer has been classified into a corresponding label. There are a total 185 labels. The challenge of this problem is the significant imbalance between the labels. This is in illustration of the first 50 labels. To optimize the problem, we will label addition data for the labels with the most data. Since the issue that the customer encounter most frequently, we will focus addressing them first. In the data processing phase, we decided to add more labels for the first 7 labels. We assigned label based on characteristics of exciting data for each label. For example, when analyze the data for the camera label, we assume that content submitted by user would contain contains what the camera. Therefore, we search for the place that contain the worst cameras the most and then use the place to label as a single data. After that, we apply the few other basic data processing steps such as text clearing and removing stopwatch. This is a data chart showing that amount of data has increased significantly after labeling. After conducting research, we decided to choose the LSTM model to resolve our problem. We choose the LSTM model because our dataset is relatively small and with an available amount to the what per sentence. Making LSTM a suitable model for this experiment. After the dataset has been processed through basic steps such as count vector laser and TF, IDF, it is split into two parts for training two models. The first part consists of the high level with the most data, while the remaining label are grouped under the other label. The two models will provide prediction result predict 1 and predict 2. After training, the first model produces a relatively high prediction and accuracy of around 80%. In contrast, the second model had a very low prediction accuracy around 15%. This is entirely list on able because the second model has too little data and too many labels. We combine the two models as follows. The first input data is passed through model mode for prediction. If the prediction result is as a label, the data will this data will be passed to model high for further prediction and output. If the prediction result from model must be different from other label, it will be final output. The output from model one for within the top five labels and is more reliable than output from model two. In short, we use two LSTM model to resolve the problem. The first model with two LSTM layers predict the top num level with the most because this model achieve an accuracy of about 30%. The second model, which was simply with only one estimate accuracy, is about 20 percent. We combine the two models for prediction. In the future, we will explore more efficient NLP model to better resolve the problem. That concludes my presentation. Thank you for listening. Thanks for listening. If anyone has any question, please ask me or email me.
Yeah, hi. Very nice presentation, UN. My only question is this, that I know that LSTM models are extremely slow. They take quite a bit of time to train. So how do you deal with, when you take the entire thing into real time, how do you deal with the high computation involved, slow process involved in LSTM?
Mm, I will build API from model and this model can predict predict VOC of customer and the result is sent to employee. The result this process is automation.
And one more question, if you please. Thank you for report. It's very interesting for me to listen to classification of customers' feedback. How do you think can we use this classification of customers' feedback not only for smartphone or for many other devices, but for services? Can we use this to estimate some data from customers of services? Thank you.
I think this problem is popular in the future. To resolve this problem, we can analyze analyze data and resolve data is difficult because it need person professional.
Thank you.
Yes, thank you.
Thank you. Thank you so much for your presentation. Moving on to our next presentation. We have Priority Classification System of Test Cases for Software Businesses. Dear presenter, could you please start with your presentation?
Hello, everyone. Uh, thank you for listening. I'm sharing my work here. Is the priority classification system of test case for software business. I conduct this paper research with collaboration with the Professor Phan Duy Hung and Dr. Vũ Chu Diệp. So in my work, there are 4 different sections. The first one is the introduction, and then the background, or let's say the theory of this paper, and then we go to the materials and methods. Then finally is the experimental results and conclusion. So first is the introduction. So the main object of this study is software testing. It is a crucial part of most software business and including gaming in this specific paper. So in the development and maintenance work of gaming software, especially online game, live ops operation is very important. It involves releasing new events, contents, features, community management, and problem management. And one of the most common trait of live ops is very reactive. Most of the time, the start of development to release to the product environment of the game in live ops is usually 1 to 3 days. In some special case, we work within like hours. With the frequent release and change we deploy to the production, live ops needs regression testing to ensure no adverse consequences have been caused by the updates. And for the regression testing, it usually doesn't run through the complete set of test case of a product, but it's a selection of highest priority test case that cover the main functions and importance features. So during my time working in my current company, I find few outstanding problems existing in the testing process in LiveOps. First is that we have a huge amount of test case, and then we have to work under the time constraint, and it really doesn't really allow the QA or the quality assurance engineer to spend too much time on prioritizing the test case. And we also don't have that details of documents to actually analyze and evaluating the relativity between requirements and test case. So in this study, I explore a solution to help reduce time spent on prioritizing the test cases by using machine learning. The solution will utilize the existing label test case to identify some patterns or keywords that indicate high priority test case and use that to mark the future new record, new test case that we put into our system. So the background of the study is deep learning. This is a branch of machine learning. It based on artificial neural network architecture and use layer of connected nodes called neurons that work together to process and learn from the input data. Here's the image that illustrate for the basic concept of it. Then the specific type of model I used in this study is convolutional neural network. Is a very popular model that mostly deal with tasks that relating to object recognition, including image classification, detection, and segmentation as well. Then now we're reaching to the part that we process the text data. Before applying the CNN in finding patterns, classify text data into wanted label, it's necessary to pre-process it first because pre-processing have improving data quality, it have enhancing model performance, and is also reducing the complexity of the data. So in hope that we can improve the the output performance of the model. There are a few common steps in pre-processing text data. The first is tokenizing. We're splitting the phrase, the sentences, or the paragraph, or an entire text document into smaller units, such as individual words or terms. And then we have the stop word removals. Is simply removing words that provide little to none value to the task that we're currently processing. Removing stop word will have decreased the dataset size, and also improve the time to train the model. And it also have increased classification accuracy. Also, we performing stemming. We're reducing the word to the stem, so it make it easier for models to process and analyze the text. And yeah, it very helpful in terms of text classification for the type that we are using in this study. And also we need the word embedding. Is very important because it transforms words or phrases from natural language into a form of numerical vector representations that can be dealt with by using the machine learning models. So about the material and methods used in this study. So about the dataset used in this research was created by the QA engineers for testing purposes in LiveOps content. The dataset is quite small because I collected from my current work. It contains 511 records, each representing one test case with summary, test type, test category, action, result, events, and the key info that we are targeting to label here is the priority. We actually are having 4 type of priority from P0, P1, P2, and P3, with P0 is the most important and P3 is the least one. So like the background has tested, we went through the data pre-processing, we're handling missing data and the duplicating data by drop it, so it doesn't cause noise to the data. And we also applying normalization. Uh, uh, we apply contraction, so the word can like be written out and no shortened form. We also removing unnecessary space, punctuations, and characters. We split the data to train set and test set, and then we pass some few parameter in tokenizing the text data. So about the model, I used the 2 branches for parallel processing with the same architecture. And then we have the and as you can see, we on the output layer we have we are using softmax output with the 4 classes representing 4 priority that we are wanting to label here. For the metrics, we are using accuracy to measure. So for evaluation, we also use the F1 score to evaluate the model performance. It is the harmonic mean of precision and recall. The F1 score provides a single measure that balances both concerns, making it especially useful when both false positives and false negatives are important. About the experimental results and conclusion, as you can see, we trained the model with 60 epochs and observed the result of training over time. You can see that the training and validation loss is decreasing over time, but yeah, as the model is still have rooms for improvement, it still have a lot of defect. The validation loss is decreasing very slow, and it is actually very high. But also at the same time, the accuracy is increasing over the period of time that we are training the model. So it's indicating that the model is actually working. but it still need to be improved. This is the confusion matrix. The models works pretty well with P0 and P1 priority. There are a few errors from for the P2 and P3, but it can be like from my observation, there's an imbalance in the data distribution as well. We have a much higher amount of the P0 and P1 test case, so maybe that is also partly the reason why it performed better on those priority. Beside the CNN models in experiments, I also prepare a classic machine learning model using logistic regression to classify the priority of the test case, and then I compare the performance between two models. So first is the table presenting the CNN model results. We have precision, recall, and event score for each of the each priority of 4 labels. And then we have the model result for the logistic regression model. As you can see, the logistic regression model performance is actually not as good as the CNN model. After the experiment, it is observed that on the training model, the loss goes down. The model does learn and the training progress is going well, and also the accuracy is increasing as well. However, the validation loss is high and reduced very slow, which can indicate overfitting. We also observed that in some case of trying on real test case text, the CNN model hasn't been able to give a clear answer on which priority is the correct one. So the model still needs further improvement to be able to perform in real environment. I'm looking at the optimizing parameters like changing the filter size, pooling size and type, adjusting the dropout rate, the batch size, and changing the layers. Also considering training with a larger dataset, so the model gets to expose to more features of text. As you can see, the size of the data in the study is quite small. So if the opportunity allowed to expose to more the bigger data size, then it may be able to improve much more. And I hope to explore combined with another application like extracting keywords, key features of a content from each requirements document. In this case, is still limited due to the lack of documents on the LiveOps team in my company. So the application of machine learning to build text classification models is well known, well researched. But myself, I find that to practice and customize it to the specific needs of each business category. For example, like the game test case is complex, but it's also very promising. It can help drastically improve the speed in handling such tasks over a period of time. It improves the quality of the task itself because it performs based on feature extraction and metrics and doesn't really get affected by bias or getting tired like humans. So I hope that in future I can work on more and focus on refining the model so it can handle even broader range of test case and especially the introduction of new test case to the set. Thank you for listening. That is the end of my presentation. If anyone has a question, so feel free to ask. I'll try.
Thank you. Thank you for your presentation. Sir, do you have any questions?
One more question, please. Thank you very much for your report. Please, how do you think, can we use some elements of artificial intelligence for in your model for in your classification system for software businesses in different industries, maybe in different services? Can we use artificial intelligence? Thank you.
I think it is possible. As I mentioned, because the object of my study is focusing on my current company and it has its limitation. I also took like reference from other software industry or companies, less in case that we have like more details documentations, we can analyze the documentation and retrieve, let's say, retrieve the key information. Then we can use that reference to actually prioritize the test case even better. And because the model, then we will have a model that combine the feature extraction and it combine the feature of the test case of each business as well. So it can learn and adapt to different contexts. And yeah, I think it can, yeah.
Thank you very much.
So if I can just ask a quick question. You immediately jumped into machine learning, but are you sure that your problem requires the power of machine learning? Did you first prove with a theorem that your problem belongs to a class, for example, of NP complete or NP hard problems? Because if not, because if you are not dealing with a problem that is that difficult, and I might be mistaken, but I think that your test case could be solved in a polynomial time quite efficiently, then you are using too much of a powerful tool for something that actually isn't for it. And with machine learning, you are always approximating. And with artificial intelligence, you are always approximating. It probably is correct, but you never know whether it is correct. And with an exact algorithm, you would know it's correct. Thank you.
Yes, it's a very good like question. I have time to think about it, and like I also mentioned in the conclusion, we try to give it like real test case, and even with the training model that give high accuracy, it still have some difficulty in identifying one. So the reason why I try machine learning is that first, I can say that is like I'm looking for a solution that can have improve the cost efficiency that can solve huge amount of test case in a short amount of time. So of course, I'm not aiming to like eliminate totally the presence of engineer in this case, but for example, an engineer can read and prioritize about 50 test case in an hour. Let's take that for example. But when using machine learning, we can do that with like, let's say 10 times faster. And after we finish that, we can just require just one engineer to just look through it and maybe editing a few test cases that they think that the model is giving not really correct the priority. But it surely, I think surely that it helps narrow down the cost and the amount of people have to be involved in the task much more. So yeah, that is my idea when I approach this one.
Thank you. Thank you so much for your presentation. Praveen sir, do you have any questions?
No, no. Good presentation.
Thank you.
Okay. Thank you. Thank you so much. Moving on to our next presentation. We have quantum encryption for low orbit vehicles. Dear presenter, could you please start with your presentation?
Yeah, sure. Hello, everyone. This one. So, hello again. We have a review paper, so not the research and such other colleagues demonstrated. It's about quantum encryption for low orbit vehicles, particularly in forest fire monitoring. So I am a Mahabad, I'm a PhD student. For introduction, wildfires serious and growing threat to our ecosystems, economies, and human lives worldwide. And nowadays, we have advanced monitoring and forecasting systems that can be essential to combat this threat. So these systems enable early fire detection, predict the spread, and support real-time decision-making for effective responses. So in our research, we analyzed opportunities of artificial intelligence in forest fire monitoring, and we consider that it's a powerful tool for solving complex problems in agriculture and forestry, and we explore algorithms such as convolutional neural networks and recurrent neural networks that demonstrate impressive results in image analysis and time series forecasting. And there are some typical CNN architecture for object detection that starts with input layer and going through convolutional, pooling, fully connected layers, and finishing output. Research indicates artificial intelligence can significantly increase detection accuracy and improve fire spread forecasting. So the role of low Earth orbit satellites, the LEO satellites are crucial for collecting high resolution aerospace data for forest fire monitoring. And the proximity to Earth provides higher spatial resolution and more frequent coverage compared to geostationary satellites. And it can allow for detailed and up-to-date information on forest health, critical for early detection and effective fire monitoring. But transmitting large amounts of data from these kind of satellites presents challenge, including ensuring high data and data rates and protecting data from unauthorized access. So we decided to, after our comparison and analyzing, that quantum key distribution can be more convenient for our case because this algorithm can offer a revolutionary approach to data security based on quantum mechanics and enable the quantum key distribution enables the creation and distribution of secret keys between remote parts with any interception attempt being immediately detected. And this provides virtually unbreakable encryption, crucial for transmitting sensitive information like forest fire data from LEO satellites, and integrating QKD into forest fire monitoring systems enhances data security and ensures the integrity of decision making. So there are higher level architecture of the proposed forest fire monitoring and forecasting system, and This system utilizes a service-oriented architecture for flexibility, scalability, and integration of various components. And the system includes layers for data collection, data processing, data processing and analysis, decision making, and communication and security. So the system employs more than AI, artificial intelligence algorithms to analyze remote sensing data, and these algorithms see and detect and classify forest fires from multispectral and hyperspectral images, and INNS predict and spread of forest fires using time series data like temperature, humidity, wind, and topography. There are some architecture for forest fire spread forecasting with LSTM layer. And clustering algorithms segment images and identify forest fire risk zones. There are variations in observed soil temperature and observed soil moisture and simulated soil enthalpy at various depths. And this figure can visualize the variations in these criteria and different depths, as I said, and which are critical factors influencing fire risk. Clustering algorithms such as K-means are employed to analyze the soil data and identify areas prone to wildfires, such as those with dry conditions or dense vegetation. And this detailed soil analysis enables informed decision making regarding fire prevention and control measures, contributing to a more proactive approach to wildfire management. And there are some comparison of various machine learning models effectiveness in predicting the spread of forest fires, and the models evaluated include CNN, RNN, and GNN and ensemble approach. Each model's performance is assessed using metrics such as accuracy, precision, completeness, and F1 measure. The ensemble method, combining the strengths of multiple models, can demonstrate superior overall performance, highlighting its potential for achieving high accuracy and reliability in fire spread forecasting. Quantum key distribution based on the BB84 protocol can secure data transmission from LEO satellites, and it can generate secret encryption keys that are impossible to intercept without disrupting quantum states, ensuring high data security. And quantum key distribution is integrated into the communication and security layer of the system. And the special quantum transmitters and receivers are installed, can be installed on the LEO satellite and ground station. And there are some quantum encryption scheme using the BB84 protocol, and this figure can describe the sender transmits photons with random polarizations, and the receiver measures them using randomly selected bases. And comparing these bases allows for the identification and discarding of non-matching results, ensuring the immediate detection of any interception attempt. And this process generates a secret key for secure communication, providing robust protection for sensitive data against unauthorized access. There are some information about cost assessment and practical implementation. That as you can see, the most cost assessment is regarding hardware, and cost-benefit analysis is performed to assess the economic efficiency, considering both direct and indirect effects. And there are expected improvements in forest fire monitoring and forecasting that can outline the anticipated improvements in forest fire monitoring and forecasting achieved by integrating LEO data, AI algorithms, and KD. Key indicators, including such fire detection accuracy, fire spread prediction accuracy, data transfer rate, and data security level, are expected to be significantly enhanced. And these improvements are projected to lead to more efficient and effective wildfire management, contributing to the preservation of ecosystems, protection of property, and the safeguarding of human lives. So there is a system performance comparison, and this figure describes the comparison the performance of the proposed system integrating LEO, AI, and KD with traditional methods. And there are some key metrics such as detection accuracy, prediction accuracy, and response time, and the results can indicate that the proposed system surpasses in traditional methods in all three metrics, demonstrating its superior effectiveness. This enhanced performance leads to more efficient forest fire management and mitigation, contributing to better protection of valuable forest resource and human lives. And to sum up, the proposed system combining LEO satellite data, as I said, has the potential to significantly improve forest fire monitoring and forecasting. And these expected improvements include increased accuracy in fire detection and prediction, faster data transfer speeds, and enhanced data security. And future research can focus on refining artificial intelligence algorithms, improving quantum key distribution efficiency, reducing system cost and complexity, conducting practical experiments, and analyzing socioeconomic impacts. So, as I said,
Thank you. Thank you for your presentation. Sir, you have any questions?
as I said, we had such a review thing, so we just in the beginning.
Yeah, so that's a nice presentation. Thank you very much. Could you give us a little bit of information on how you can forecast forest fires through this model?
So, sorry, I have some echo.
I'm asking how you
Yeah,
can
I got it. Sorry.
forecast,
I'm
predict
just
forest fires.
okay.
What you exactly mean by forecasting? And how
Yeah.
can your proposed methodology with respect to quantum key encryption help you?
Yeah. Thank you for the question. In forest in forecast fire, we all know that space technology can be really efficient to monitoring, to get more clear accuracy data. And in this case, actually, I'm more focused on encryption of low orbit aircraft. And such as example, we took forecast fire monitoring because we need data, and we think that while we satellites, how we can improve the security of data transmission. So the focus is of our research is obtaining security of information. So I'm sorry if there was little confusion.
Yeah, so again, I understand that you are more focused on security aspects. Uh, but again, these methods are basically random methods, so there is not always 100% accuracy.
Yeah.
All right. So, can you elaborate on some measures that you generally use to measure the accuracy of your estimate of how secure your system is? So, how do you measure how secure
So,
your system is?
okay, as I said before, it's just our suggestion, proposal, and we, to be honest, don't have any system. And as we wrote in our paper, we just suggest this system, and this metrics that I mentioned before, like. Um, in according to depth and according to the weather conditions, and we can so okay, sorry, I'm confused. I mean that this matrix for maybe this matrix for fire forecast it doesn't don't have any influence here for encryption, but they should be taken into account when we are receiving data from satellites, and we can depending on this data decide how which encryption could be more efficient for these situations.
All right, thank you. Thank you.
So I have a question, if I may.
Yes.
You were mentioning quantum algorithms and implementation thereof. So I'm interested in what type of quantum algorithm you implemented and what quantum effect did you use for this communication and encryption?
So we explored quantum key distribution based on BB484 protocol, as I said before, and second part was about
what quantum effect did you use? There is a type of quantum effect that is being used for communication at large distances, which Einstein called spooky action at a distance. So what effect did you use?
what effect we use. So, oh my gosh. We comprise of effectiveness different machine learning models for protecting the spread of forest fires. And in the table 1, we show the accuracy, precision, completeness, and F1 measure. And these machine learning models include SNN, INN, and GNN algorithms.
No more questions, but I presume you would need the quantum entanglement. Look into it, quantum entanglement. Thank you.
Thank you. Thank you for your presentation. Alexander, sir, you have any question? Okay. Moving on to our next presentation, we have robust control strategies for emergency situations. Dear presenter, could you please start with your presentation? I repeat, the paper title, Robust Control Strategies for Emergency Situations. Dear presenter, could you please start with your presentation? Okay, moving to our next presentation, we have paper title, Towards Sustainable Agricultural Development in Developing Countries Through Advanced Frugal Innovations, a Scoping Review and Research Agenda. Dear presenter, could you please start with your presentation?
Thank you so much. Can I just first get an indication that you can hear me? Am I audible?
Yes.
Okay, perfect. Thank you so much. Okay, I'll just share my screen. Mm. Yeah, you can see my slides.
Yes, we can see your slides. You may please start with your presentation.
All right, thank you. Good day, everyone. I hope you are well. So I will be presenting on a scoping review entitled Towards Sustainable Agricultural Development in Developing Countries, a Scoping Review and Research Agenda. So I'm currently conducting research on an innovation type called Advanced Rural Innovations. And this is a collaborative research between Stellenbosch University in South Africa, the Institute of Economic and Cultural Geography in Hanover, Germany, and the Indian Institute of Technology, Madras. And this research group is collectively known as AFRIN. So my research looks into the development of AFIs in the agricultural and agro-processing industries in South Africa. And in order to do this, I first conducted a scoping review to map out the extent and range of existing literature. So this is by way of introduction. I'm Fisiwe Hlophe, and I'm an industrial engineer, and I'm currently enrolled for a master's in engineering at Stellenbosch University. So let's first provide context into why the agriculture industry is so important. Well, the agriculture sector is typically an important source of foreign revenue and employment growth for developing countries, and South Africa is no exception. This sector encompasses all the activities and the industries that are involved in cultivating plants and rearing animals for fiber, food, medicine, and other activities that sustain and maintain human life. Agriculture contributes into poverty alleviation in developing countries in three ways. One, reducing food prices. Two, creating employment. And three, increasing real wages as well as improving farm income. However, this sector is currently plagued by challenges. So for one, the effects of climate change, such as increased frequency of extreme weather conditions and that threaten agricultural productivity. And this is a problem since agricultural production in sub-Saharan Africa mainly relies on rain-fed farming systems. Developing countries also experience limited access to water, fertile land, and financial resources, which hinder sustainable development in the sector. Developing countries also lack access to advanced technologies that could be employed in agricultural practices, which thereby reduces efficiency and productivity in the sector. And all these challenges underscore a need to address them through innovation, policy support, and sustainable practices to ensure food security and resilience in these developing countries. Now, this research focuses on a type of innovation called inclusive innovation or innovation for inclusive development. Now, this type of innovation aims to improve the living conditions of marginalized communities by creating employment opportunities and fostering the creation of products, services, and models that target BOP societies. Now, there are many alternative forms of inclusive innovation, but of interest to this study are frugal innovations, FIs in short, and advanced frugal innovations, AFIs, which also draw from the principles of frugality. And inherent to all these innovation systems are interconnected structural components, the actors who are the drivers of the innovation itself, institutions which are the frameworks of regulation that minimize uncertainty in interactions between the actors, ensuring that they engage constructively, interactions which refer to the dynamics between actors that can spread from individual to dense and vast networks, and finally infrastructure, which refers to the physical amenities, knowledge, and financial infrastructures that facilitate and encourage these innovations in question. So what are FIs? These focus on redesigning products, services, and business models to reduce complexity and total lifecycle costs. They target BOP societies and have three main aims. One, substantial cost reduction, and this can be done either by purchasing products that are cheaper alternatives to existing products, or by reducing the use of raw materials and finances, as well as the reuse of components. Two, concentration of core functionalities by omitting any unnecessary features. And three, optimize performance level through product architecture and ideal coordination of components. And an innovation is classified as frugal if it meets all three defining criteria simultaneously. And the primary aim of FIs is to meet a local need. Now, in contrast to AFIs, these combine socio-economic and environmental benefits by expressing their frugality through competitive prices and sustainability. They emphasize the use of sophisticated technology, research and development, and rigorous design rather. AFIs follow a systematic and methodical development process, and they intentionally set constraints on the amount of resources that are consumed when fabricating a product. Now, the deliberate limitation of resource usage leads to the creation of lighter products with lower energy consumption, and this ultimately leads to lower greenhouse gases during production owing to the lower resource use. AFIs are also competitive in all market geographies and are not exclusive only to BOP markets. Now, this scoping review was done by following the Joanna Briggs Institute framework for conducting scoping reviews. The aim of the study was to investigate AFIs developed in and for the agriculture sector in developing countries, the factors that facilitate and or inhibit their development, and the scaling beyond the regions where they are initially implemented. Now, the following research questions help to address this aim. One, what is AFI and how does it differ from other innovation types? Two, what are some examples of AFIs in agriculture in developing countries? Three, what factors lead to the development and scaling of these innovations? Four, what are the hindrances to their development and scaling? And finally, what is the connection between AFIs and agriculture and sustainability? Now, multiple electronic databases were used to inform the eligibility criteria for the study, which include the Stellenbosch University Library. And the bibliometric data was conducted by correlating search terms, which resulted in a yield of 2,000 plus records, of which only 30 met the eligibility criteria. And now we'll discuss the results that were obtained from the 30 records selected for the study. The software program Bibliomatrix, which is developed in our programming language, was used to facilitate data analysis and visualization to map out the extent of literature in the study. So for starters, this graph, it shows the number of articles that are produced by authors from different countries over time, and it highlights a significant disparity in the contributions from developing and developed countries. This graph shows the number of citations per country, providing insight into the impact and influence of research from these different regions. And then this figure is a map of country collaborations from the sampled literature included in the study. And the magnitude of each country's contribution is represented by the richness of the blue shading. The connecting lines on either end indicate the collaboration between the countries, and the thickness shows the frequency of these collaborations. Now, to note, India is a significant contributor amongst developing nations, and this is evidenced by its deep blue shading. And this is expected because the ideas of frugal innovation and advanced frugal innovation originate from India. So what are the learnings from this bibliometric search? So we have found that there's a stark imbalance in global research contributions, and most publications come from authors in developed countries, with authors from developing countries represented only by South Africa, India, and Brazil, and their publication numbers noticeably lower than their counterparts in developed countries. And propositions, of course, to address this disparity include investing in research infrastructure and capacity building in developing nations, encouraging collaborations between institutions in developing and developed countries, policy support through government incentives, as well as funding through either governments, financial institutions, and non-governmental organizations. The second research question necessitated the differentiation of AFIs from traditional frugal innovations, which are noted in this table here. And I want to highlight firstly that AFIs emerge from an artificial scarcity, which contrasts from a natural scarcity of resources that exists in traditional frugal innovations. And AFIs are always of high quality, as opposed to traditional frugal innovations that have a large range of quality depending on how they are manufactured. And because the development process of advanced frugal innovations is systematic and methodical, they are suitable for mass production, which cannot be said for traditional frugal innovations that can also make use of ad hoc principles and trial and error to manufacture. And finally, AFIs intentionally aim to achieve sustainability, which is in contrast to frugal innovations because those emerge from a local need and they do not aim to meet some green standard. So if sustainability is achieved in them, it's usually as a result of coincidence. Now, during the study, it was discovered that agricultural AFIs can generally be categorized into 4 types. These are smart farming solutions, agro-advisory extensions, climate resilience tools, and marketing access platforms. Smart farming solutions introduce precision in agriculture either through technologies like sensors or drones. Agro-advisory extensions facilitate the dissemination of information between different actors and different institutions, for example, between farmers and their subsequent suppliers. Climate resilience tools refer to the strategies, practices, and technologies designed to help agricultural systems withstand and adapt to the impacts of climate change. And finally, market access platforms involve the development of digital platforms that allow farmers to connect better with their buyers. Now, the following factors were found to facilitate the development and scaling of agricultural AFIs in developing countries. 1, everyday confrontation with regional conditions that evoke mindsets that may embrace AFI solutions. Secondly, AFIs require a highly skilled workforce and technical expertise owing to the use of more modern manufacturing techniques and modern technologies. AFIs require a connected economy, or rather an innovation ecosystem, in order to develop. They require the availability and use of suitable materials and advanced technologies. They must be developed using direct input from end users in order to ensure relevance, and the market perception of them affects their pricing and their accessibility. With regards to the final research question, it was found that AFIs contribute to sustainability through their emphasis on resource efficiency, cost effectiveness, and environmental stewardship. So now we propose a research agenda to identify conditions that further support the development and scaling of advanced frugal innovations in developing countries. And we found that by examining specific cases, the research can uncover patterns and the factors that enable their successful implementation and scaling. And then these learnings can then further be used to develop a framework that can be used by policymakers, researchers, or the practitioners to facilitate the sustainable and inclusive growth of advanced frugal innovations. So thank you so much for paying attention, and I'll welcome any questions that you have at this juncture.
Yeah, could you go to your results slides?
Yeah. From which part?
Yeah, the bibliometric analysis.
It's from here.
Yeah, the next one. So what does this graph tell us?
So this shows us the different citations, number of citations from different countries, basically to compare citations between developed and developing nations. And number of citations basically shows us how much impact particular research has. So if we have more citations from a particular country, for instance, it shows us that the research from that area has more impact into the topic of advanced frugal innovation, specifically in agriculture and agro-processing, as opposed to other
So,
ones that have fewer.
all right, I get that, but these are citations of different countries, and the
Absolutely.
citations of what topic of study?
Of specifically advanced frugal innovations in agriculture, in agro-processing.
All right,
And
so these are
yeah,
citations,
agro-processing, yeah.
okay, targeted towards AFIs, right? And you are mapping that, you're taking a positive correlation between citation and the impact in real world. Is that correct?
No, what I am doing is basically juxtaposing how much citation is there in nations that would be classified as developed and those that would be classified as developing, because my research focuses on developing nations. But this was to see what actually has been done on this topic anyway and everywhere. And this basically just shows the gap in existing research on this topic between the two nations. And yet the idea in and of itself stems from a developing nation.
So what was the conclusion again, basically by seeing this figure?
So the conclusion is that there's a big disparity, there's a big research gap in this type of innovations. And yet we've identified in through a few cases that they're actually useful and they're great and that they're sustainable. And they're also important in agriculture because it's a big form of economic revenue in a lot of developing nations. So we're showing that there's a lack of research in it, and we say that it must be explored to facilitate the growth of this sector, which is important in developing nations, essentially.
So can we go to the
But we're
next
saying there's more.
slide?
Okay.
The one where you have the map?
This,
Yes. So this tells us
yes.
that there is a huge disparity between in the contribution of different countries towards research into AFIs.
Yes. And the collaborations between them. Absolutely. And that's what these connecting lines are showing us.
Okay.
That.
So my question would be, what does it have? How relevant is this figure to your basic research question of using an advanced frugal innovation into developing the agricultural practices in developing nations?
So you'll see in the research agenda, I proposed examining specific cases, which is what my research.
I'm sorry to interject you,
Okay.
because
Okay.
in the real sense, it's not about research, but it's about government policy, funding, collaboration, subsidies, etc. So have you made a study on those lines, is my question.
And government. And to understand your question correctly, on those lines, you mean the incentives behind research,
Yeah,
or
no,
what
no, not
facilitates the
behind the
research?
research. Like when, so as far as I understand, correct me if I'm wrong, your research aims to propose advanced frugal innovation strategies for development of agricultural practices in developing countries. Is that correct?
No. So what my research aims to do is to understand how they actually develop in across different sectors, right? And then from this learning to then propose a framework to say, okay, this is what actually helps them develop, and therefore this is what policymakers should do, this is what governments should do, this is what practitioners should do to develop the advanced frugal innovations,
Oh,
because
yeah,
we think they're these great
that is what I'm
innovations.
referring to. So, to that
Okay.
to that effect, you must have studied the percentage of expenditure or government budget allocated for the agriculture, government incentives for farmers, especially the marginalized communities. Um,
Okay.
etc., etc.
Yes.
Yeah. Have you looked
Okay.
at those
Yes.
inputs?
Absolutely. And we found that they are close to non-existent, especially in developing nations. Hence the
Non-existent?
disparity. I think it was mentioned. Well, not non-existent, close to non-existent in developing nations. Like I said, it's a niche topic. Advanced frugal innovations
yes,
isn't well
true.
known. So, which was discovered by the bibliometric analysis. And it's one of the propositions that I made in an earlier slide about ways to mitigate this disparity that currently exists. So through policy support, through funding, etc.
All right. Great. Well done.
Thank you. Thank you so much for your presentation. So you have any questions?
One more question, if you please.
Yeah.
I know that some countries use rotation of crops for sustainable agricultural development. What do you think about it? Is it a real solution for sustainable agricultural development? The changing of technical crops and someone else. Yes. Thank you.
I think it's a solution, but I think in terms of classifying it as an advanced frugal innovation, I wouldn't classify it as such. So with advanced frugal innovation, there are certain criteria that an innovation must meet to be qualified as advanced. Otherwise, it just falls as a traditional frugal innovation. So there must be some form of research and development that went behind making it. There must be a systematic and methodical process in how it was manufactured such that you can implement it elsewhere. And this also applies in terms of processes that we classify as advanced frugal innovation. I think in terms, is it effective? I'm not so sure. It depends, but also not in this case, especially because I want to think of a situation like South Africa. We have ongoing droughts at times, and crop rotation wouldn't really still help us mitigate productivity if our problem is the fact that like there's a big, lack of water. So South Africa is classified as water stressed because its annual rainfall is less than 60% of the rest of the world. So I think that in that sense, it wouldn't really be an advanced frugal innovation, but rather a more frugal one because it works for that particular context where you're applying it, and it wouldn't really apply everywhere. And yet advanced should work everywhere where you try to, implement it rather.
Thank you very much.
Just a quick question, if I may. If we would take a number of citations as a relevant measure in this instance, although I'm not exactly sure that it would be, but let's take it as such. You have taken the measure as absolute. For example, any kind of analysis you do, almost any kind, United States, China, which you have forgotten to mention, and the United Kingdom will be at the top. But that doesn't mean that the rest of the world, is in a bad shape. Because when you take it relatively, for example, with in mind, at least with the in regard to the number of people, then you will see that there are other countries that are actually doing quite well, and that they're doing well for their situation or far better.
In terms of, I do not understand, in terms of what? Research output or in terms of the actual innovation itself?
You can take anything. I have recently researched, I have recently been on a research that has done a bibliometric analysis. We have done almost every analysis that bibliometrics has, almost every analysis. The article had about 130 pages, and the China, United States, and United Kingdom were at the top at almost every analysis. But that doesn't mean that somebody else is not doing well. In fact, when we measured relatively, it turned out that there are countries that do incredibly well. For example, South Korea, which has only about 50 million people, was a powerhouse. We were amazed how well they did when you take into account, for example, population. Or, for example, quite often China is better or much better than the United States, quite often. But when you
terms
take
of
into
what?
account any kind of measure from bibliometrics, there are
Okay.
many, there are many. But when you take into account population, then quite often the United States comes at the top. So I guess you didn't take any measure relatively, you just took the absolute value.
I think either I'm having trouble fully comprehending your question, but I I think that's a very generic statement to actually make, because which is why I kept interjecting and asking in terms of what. So when I challenge you to actually,
In terms of
okay,
your citations, you were taking citations as an indicator for what?
okay.
You were
So
taking
I think it's,
as an indicator for something, for what?
can I speak?
Sure, I'm waiting.
Oh, okay, great. So I think it's very important that specifics are actually also mentioned here. Like I did mention, it's a niche topic. And then when it comes to actual research, just general research, there is existing disparity always in other developing and developing nations for whatever reason. And I think reasons may differ depending on what topic you're actually looking at. But I think in this case, I can't speak for whatever you were looking at, but I can speak for advanced frugal innovation in agriculture specifically because I did that one and I'm well versed with that one. But I can safely say that it wasn't just like any nation in like a developed country that was prominent. It had to do with the ones that are actually involved in these researches and actually had cases relating to advanced frugal innovation in either agriculture or agro-processing. Like I said, my research focuses mainly on developing countries and how they can build their prowess with regards to that. And the purpose of that citation was to actually juxtapose the disparity in terms of like academic output, because it is what informs research, right? So I think if we're talking about disparity in terms of like output and bibliometric data, then we can generally say, as you're saying, that there's disparities between developing nations, and maybe China and the United States have more publications because, like you said, they have higher populations, or they've got more people, or they have more resources and financial resources in terms of that output. That's another conversation for another day. And if that is a disparity, then it is something that we can look into and look into the causes of disparity. But I think it's subjective to whatever topic that we're looking at. And I think it's very dangerous to make generic assumptions. In my short life here in academia, I've learned that the hard way.
Thank you. It's not generic, I was specific. And the last question, I promise. Did you do co-citation and co-reference analysis? And what do they show if you did?
Yes, I do, but the details of that are actually in the scoping review. If you read it, I was just limited by the time limit of this presentation. But yes, I did do them, and they revealed the same output I had in the rest of the bibliometric analysis, the stock imbalances. Yeah.
Yeah, thank you so much for your presentation. It was a wonderful presentation. So this
Thank you.
brings us, yeah, thank you. This brings us to the end of our presentations. I would request our session chairs if you all could share your insights and feedback on the presentations that have been covered in this session. So, if you could share some valuable feedback and your insights to all our presenters.
So thank you very much for all visitors of our meeting. It was very interesting to find new and very unique information about different topics. I think that we had start with algorithmic and information support in atmospheric air quality systems for monitoring. It was very interesting approach for investigation of air pollution and different ways of environmental protection. It's very interesting to listen to customers' feedback via an example of smartphone suppliers in Vietnam. And I think, and I can agree with speaker Nguyen Ngo Thu, that this algorithm or this classifying we can use not only via the example of smartphones, but in other cases for other trade goods and maybe for other services, of course. It was very interesting to listen to priority classification system of software businesses, and it was very interesting algorithm decision for this classification, and report about low orbit vehicles. Maybe this is connected with our current realities of huge development of drone equipment, maybe some other devices connected with agriculture, maybe with navigation, maybe with military for military purposes, etc. This is also it was also very interesting report. And finally, we have a report about sustainable agricultural development and different approaches for using of frugal innovation, advanced frugal innovation. This is also very important problem, and I think that this report will help to all our mankind in coping with food supply and different food problems we have in developing countries, and not only on this territory, but in some other territories also. I would like to thank you for attention, for your report. I'm proud that I take part in this meeting. Thank you very much.
Yeah, I'm Professor Praveen Chapala, and I thank all of the participants for their great talks. Point number one was we had a diverse set of papers in this session and with a diverse set of applications, which is really interesting. And the second takeaway is that there is a lot of artificial intelligence and machine learning happening all around us, and this session is not so different from it. And I see that there are quite a few PhD students who have presented in this session. I wish them all the very best, and I really hope that some of the questions asked would help them further their research. I also greet my co-chairs and Alexander, Professor Alexander and Professor Robert. And I also thank the organizers, and I congratulate Aditi for doing so well in this session. Thank you very much.
Thank you, sir. Thank you so much for your valuable insights. Professor Robert, you have
course.
any?
Of course, thank you. Just a quick note, I also greet my co-chairs, and Professor Prevans said something that is quite deep, actually, and that is that we are currently living in an age that will perhaps someday be called an industrial revolution by itself because of the explosion of the artificial intelligence. But let's not forget that artificial intelligence is quite old. And it only came what it is in the last few years. So the question now is, what is the next step? What is the next great thing? Is it continuation of the artificial intelligence? Is it quantum computation? Or is it something else? So I would urge everybody to try to answer that question, because that will be great research with great results. All the best.
Thank you. Thank you so much. Thank you, all our session chairs, for your valuable insights and feedback, to all our presenters. So I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. We would be really happy to have you all in the 11th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2025. I would like to thank our session chairs for chairing the session. Professor Alexander for chairing the session, and Professor Robert and Professor Praveen for chairing the session with us. A token of appreciation to all our chairs on behalf of Team ICICT 2025 and Global Knowledge Research Foundation and partners. Thank you all. Thank you for your valuable presence. I kindly request you all to please switch on your cameras for a quick snapshot of the virtual conference. Can we have the cameras on? Thank you all. Thank you so much. Stay safe and take care. Bye.
Thank you so much.
Thanks, bye.
Thank you.
Thank you for organizing this report. Thank you very much.
Thank you, sir. It was a pleasure.